All right, let's look at a couple other series using the ratio test. So we're just asked to find what does the ratio test tell us about these two different series. Now we already should recognize the first series, the summation from 1 to infinity of 1 over n. That's just our harmonic series, and we know that diverges. We've already proved that. But let's look at what happens if we try to apply the ratio test to it. So we have a n plus 1 over a n, and that's equal to 1 over n plus 1. Okay, I'm again dropping the absolute value signs because n is positive, and times n over 1, right? I'm just taking the reciprocal of the denominator, right? So, and then, so that's just n over n plus 1. And the limit, as n goes to infinity, of n over n plus 1 is just equal to 1. So this is a case where our ratio test is inconclusive. Inconclusive, right? We can't tell anything from the ratio test. And this other series looks very similar, right? It's basically 1 over n, but it's alternating in sign, right? So when n minus 1 is positive, then, or sorry, when it's even, when n minus 1 is even, then it's positive, and when it's odd, then it's negative. Okay, so it's the same series, only alternating signs. But again, if we look at the this with the ratio test, now the ratio test, we're taking the absolute value of the ratio of the consecutive terms, right? So I can write it out for you here. We get, minus 1 to the n plus 1 minus 1 becomes to the n, and this becomes n plus 1, and then times the reciprocal, so we have n over minus 1 to the n minus 1. Okay, absolute value of that. Now I do need that because we have these alternating signs. But you can see that if n is even, then n minus 1 is odd. And if n is odd, then n minus 1 is even. So this essentially is negative 1, but then when I take the absolute value of it, it's going to be positive. So I'm just going to cross that out. And so you end up with just n over n plus 1, just like you did with the harmonic series. So again, the limit as n goes to infinity of n over n plus 1 is equal to 1, and so our test is inconclusive. So the next test that I want to introduce is the alternating series test. Because if you look at that alternating harmonic series where the sign is alternating positive, negative, positive, negative, positive, negative, it sort of seems like that should converge, right? So, your sums, if I were to plot my sums on a number line, so if this is 0 and say this is S1, right? And 1 over n is a decreasing function, so the consecutive terms are decreasing. So I'm going to have sums that look like that. So this is A1, and then A2 is the opposite sign. So I'm going to come back, but not as far as I came the first time. It's not as big as A1 because it's a decreasing function. So here's A2, and I have some S2. And then my third term, which there should be meant that to be A2, right? And then my third term, A3, is again going to be smaller than the others, so it's going to come back in the other direction, but not as far, right? So it kind of makes sense that this converges. And if you looked at the terms, you'd see, okay, they keep getting smaller and smaller and smaller, and they're alternating signs. Seems like it should converge. So there's this alternating series test, which actually tells us that if we have an alternating series where we have, and it's decreasing, right? So the n plus 1 term, they're all greater than 0, so they're positive, but, so an is positive, but it's decreasing, right? So the next term is always smaller than the term before it. And if it's an alternating series, if it has this minus 1 to some power, so the every other term is the opposite sign, then if the limit of an as n goes to infinity is 0, then it converges. Okay, so it turns out that this converges. We have, so I'm just going to go ahead and do example 5 as well, because it's related. So 0 is less than the n plus 1th term, which is less than 1 over n, right? And so, and the limit as n goes to infinity of 1 over n is equal to 0. So the alternating series test says that this series converges. So the series converges by the alternating series test. All right, so we have another test under our belt. And I'm going to add that to our table. Okay, so I've created, this is just the same table I had in the last section, except I've added now the ratio and the alternating series test. So this would be a good sheet to keep handy while you're doing your homework, so that you know what tools you have available to you to solve these problems. Okay, so you are ready to start your discussion questions, and I will see you in class.